You have the same amount of hair as a chimpanzee. Yes, you read that right. The same number of hair follicles packed into your skin from head to toe. So why can't you see it? The answer is, most of that hair is tiny. So tiny, it's almost invisible. Somewhere in our history, something happened to human hair. It didn't disappear, it just shrank down to almost nothing. And here's the strange part. Scientists still don't fully agree on why this happened. There are several theories, and today we're going to go through the most interesting ones. Let's start with the most popular idea. It's called the cooling down theory, or the thermoregulation theory. Millions of years ago, our ancestors lived in Africa, out in the open grasslands. And Africa was hot, really hot. To survive, early humans had to hunt for food. But this wasn't quick hunting. Early humans didn't have sharp claws or super speed. Instead, they used a strategy called persistence hunting. That means chasing an animal for hours, sometimes for an entire day, under the burning sun, until the animal simply collapsed from exhaustion. Here's the key detail. Most animals can run fast, but only for a short burst. After that, they overheat and have to stop and rest. Humans are different. We can keep moving for a very long time without overheating. Why? Because of sweat. Humans have millions of sweat glands all over the body, way more than almost any other animal on the planet. When we sweat, the moisture evaporates from our skin and pulls heat away with it. This is a very efficient cooling system, but there's a problem. Thick fur traps heat close to the skin. It blocks airflow and stops sweat from evaporating properly. So thick fur and heavy sweating simply don't work well together. This means early humans with less body hair could hunt for longer periods without overheating. They could chase prey farther in hotter conditions without collapsing. Over thousands of generations, this became a survival advantage. The humans with less hair survived more often, ate more often, and had more children. Those children inherited the same trait. Generation after generation, human hair became thinner, finer, and less visible until we ended up looking the way we do today. That's one theory. But there's another one, and it's a little less pleasant to think about. It's called the parasite theory. Thick fur might feel warm and cozy, but it's also the perfect hiding place for lice, ticks, fleas, and other tiny parasites. These parasites don't just cause itching. Many of them carry dangerous diseases that can spread through a group very quickly. So less hair meant fewer places for parasites to hide. Fewer parasites meant fewer infections, and a healthier, longer life. Once again, natural selection favored the humans with less hair because they simply survived better than the ones covered in thick fur. Now here's a weirder idea, one that even scientists argue about a lot. It's called the aquatic ape theory. This theory suggests that at some point, our ancestors spent a significant amount of time living near water, maybe along rivers, lakes, or coastlines, wading and swimming to find food. If you look at animals that live in water like dolphins, whales, and hippos, you'll notice they also have very little hair. That's because thick fur doesn't work well in water. It gets heavy, soaks up moisture, and slows the body down while swimming. This theory is controversial, and not everyone in the scientific community agrees with it. Critics say there isn't enough solid evidence to prove it, but it's still a fascinating idea to think about. Could time spent near water have played a role in shaping human skin? We're still not completely sure, and this debate hasn't been settled. There's also a theory about attraction, called sexual selection. This idea works a little differently from the others. Instead of survival, it's about mate choice. The theory suggests that smoother skin might have looked healthier to potential partners. Healthier skin could signal fewer parasites, fewer infections, and better overall fitness, which could mean more fertility. So maybe over time, early humans simply started preferring partners with smoother, less hairy skin. If that preference continued for thousands of years, it could have gradually shaped how humans look today. This idea isn't proven either, but many scientists think it worked alongside the other theories rather than acting alone. There's one more piece to this puzzle that's easy to forget. Clothing. At some point, early humans learned how to make and wear clothes from animal skins and plant fibers. Once humans could wrap themselves in warm materials whenever they needed to, the body didn't have to rely on its own fur for protection anymore. Clothes could be put on in cold weather and taken off in hot weather, which is something fur can't really do. This gave early humans a huge advantage. They could adapt to almost any climate on Earth, from freezing mountains to scorching deserts, without needing to evolve a different type of fur for each environment. Some scientists believe this invention of clothing may have removed a lot of the pressure to keep body hair at all, making it even easier for humans to lose their thick coat over time. Now here's something interesting to think about. If having less hair was so useful for survival, why do we still have thick hair on our heads, in our armpits, and in a few other areas? Shouldn't evolution have removed all of it if less hair was such a big advantage? It turns out some hair still has an important job to do. Head hair protects our scalp from strong, direct sunlight, which can cause burns and overheating. It also helps trap warmth close to the head when the weather turns cold, which matters a lot since we lose a large amount of body heat through our heads. So losing all of it completely would not have been a good idea for survival. Armpit hair and other body hair might work a little differently. Some scientists believe this hair helps trap scent released by sweat glands in those areas. That scent could have played a role in attraction between potential partners, similar to how many other animals use scent to communicate. So it's not accurate to say humans lost fur completely. We lost it in the places where it wasn't needed anymore, and we kept it in the places where it still served a clear purpose. That's a very human kind of evolution. Smart, efficient, and a little bit strange when you really think about it. So which theory is the correct one? Scientists have spent decades trying to answer that, running studies on sweat glands, comparing DNA between humans and other primates, and even studying isolated tribes that still hunt using persistence hunting today. But there's still no single experiment that can travel back millions of years and prove exactly what happened. That's the tricky part about studying evolution. We can't watch it happen. We can only look at the clues left behind like fossils, genetics, and the bodies of animals alive today and try to piece together the most likely story. So here's the real answer to the big question. No single scientist has 100% proof of exactly why humans lost their thick fur. It's probably not just one simple reason. It's most likely a mix of several factors working together over a very long period of time. Cooling down during long hunts, avoiding dangerous parasites, possibly time spent near water, and even mate attraction may have all played a part at different points in human history. Evolution rarely has one clean, simple cause. It's messy, it happens gradually, and it takes place over millions of years, shaped by countless small advantages that added up over time. But one thing is very clear. Losing thick body fur helped early humans survive and thrive in ways that other animals simply couldn't. It allowed us to hunt longer, travel farther, and adapt to environments that would have been impossible to survive in with a heavy coat of fur. So next time you look in the mirror, remember this. You're not missing something that other animals have. You're not incomplete or unfinished. You're wearing an evolutionary upgrade, one that helped your distant ancestors outlast, outrun, and outlive almost everything else roaming the ancient African savanna.